Welcome back everyone. In this video we are going to solve question number 58, which is length of last word. We are given a string S consisting of words and spaces. We have to return the length of last word in the string. And a word is a maximal substring consisting of non-spaces characters only. Let's see example 1. In example 1, the string is hello world and the last word is world, which has a length of 5. So we'll return 5 as the length of the last word. In example 2, the string is fly me to the moon and the last word is moon. So we'll return 4 as the length of last word. In example 3, the last word is joy boy, which has a length of 6. So we will return 6. We are also given the constraints that the length of the string can be 1 to the 10 to the power 4. S consists of only English letters and spaces. There will be at least one word in a string. So by seeing these examples, you might have already guessed the solutions. We'll solve this question using two approaches. The first approach is traversing the string from the start towards the end, and the second approach is traversing the string from right side toward the left side. Let's see the first approach, in which we'll traverse the string from the left toward the right. So what we'll do is we'll start from the left toward the right and keep on counting the length of each word. And whenever we encounter spaces, we'll skip those characters, and when we encounter a character again, provided that the previous character is a space, then we will reset the length of the word. We'll maintain a variable, for example, the length of word, which will initially be 0, right? And the length of our string will be s dot length. Now I'll start the loop from 0 towards the end of this string. Now if the character at this position is empty space, then we will skip this character. But if it is not an empty character, then we will count this as the length of this word, right? Okay, now let's see example 2. In this, when we were traversing over these empty characters, we will skip all these. Okay, but when we come at F, L, Y, we'll count these words as 3 characters long. Now you encountered space again. So now what you will do? Will you reset the length? No, you cannot. When we were traversing the moon, the length of the word will be 4. And when you encounter space, you cannot just simply reset the length of this word. You have a condition on which you can reset the length of this word. And the condition is, if you encounter a character and just before that character there is a space, then you can reset the length of this word. So when you have the length of the word as 3 and then you encounter a space, you do not reset the length of the word you have collected up until now. Now you are on M. Okay, so here you see you are at a character and the previous character is a space, which means this is the beginning of the next word. And in this case you can reset the previous length of the word and start afresh. So the condition is, if I minus 1 is greater than or equal to 0 and the previous character is a space and the current character is not space, then you can simply reset the length of word to 0. Okay, and finally we will return whatever length of word we have. Okay, so let's see. Okay, so our all the test case has been passed, and now we'll try to submit and see whether it can pass all the test case or not. Okay, so our solution has been accepted. This solution requires traversing the whole string from left toward the right. So this solution requires big of an execution time. Okay, now what if we traverse the string from right toward the left, and whenever we encounter the word, we will know the length of that word and we can terminate early. Okay, we don't have to traverse the whole string. So for example, in these strings we'll know the length of this word, that is 4, and we don't have to traverse the leftover string, right? So the approach is we will traverse from right toward the left. First, we will skip all the space characters, know the length of the last word, and we'll keep on traversing from right toward the left until we encounter a space. And whenever we encounter a space or the start of the string, we will terminate. Okay. So the approach is, so we'll start from the end. So let's say j will be s of length minus 1. So j is at the last character. Okay. So while j is greater than equal to 0, and if s at j is space, okay, we will reduce j. So we'll position the j at the last non-space character. Okay. Now j is at the position where there is no space. So last non-space character. Okay. Now we will know the length of that word. Okay. So while j is greater than equal to 0 and s at j minus minus is not equal to space, then we will increase the length of the word, and finally we will return the length of word. So what we did is we skipped all the space character from the end. Okay. Now j is positioned at the non-space character. Now we will count all the non-space character, and if we ever encounter a space, we will break out of this loop. Okay. Now after breaking out this loop, we will be able to return the length of the last word. So let's see example 2 here. Okay. So the first while loop will remove all these space characters, and the second while loop will count for n, o, and m, and then it encounters a space character on which this loop will terminate. Finally, we will return the length of the word moon. Okay. Let's see example 3. In example 3, there are no space characters. So j will still be at the last character. And from second while loop, we'll be able to count the length of the last word and finally return the last word's length. Now let's submit this, and our solution has been accepted. Now, just to recap, we have solved this problem using two approaches. In the first approach, we traverse from the left toward the right, and in the second approach, we traverse from right toward the left. Only difference is when we traverse from the left toward the right, we have to traverse the whole string. In approach 2, we don't have to traverse the whole string. We just have to traverse until we traverse the last word. So that's the only difference between these two approaches. But the execution time taken by the approach 2 is very less because we are not traversing the whole string. But still, the time complexity for the approach 2 will remain big of n.